Good afternoon, all of you. In today's session, we are going to have, a video, a session on the matter in our surroundings. And in this video, mostly I will be talking about that very important topic, that is liquefaction of gases. We are going to talk about that. But then there is a homework which is the link to which is given in the description box below. So that homework has 10 MCQ questions from matter in our surroundings. So after seeing the video, you can just try the homework. There are 10 MCQs, so you can send the answers as and when they are ready. You don't have to send elaborate calculated answers, just have to send the answers. Now, but in the video I'll be talking only about liquefaction. There are a couple of liquefaction given in the homework PDF as well. So let's just talk a little bit about liquefaction. Now, what exactly is liquefaction? You see, what happens is that gases are very important for us in so many things. We breathe oxygen, we give out carbon dioxide, we use LPG in cooking gas cylinders. But storage of gases, how do you confine gases? How do you store a gas? So in LPG cylinders, you have to compress the gas, right? And you have to compress it into a cylinder. That makes it easy to store it, and most importantly makes it easy to transport. See, storage is important, transportation is also important. You must have a means to transport the LPG from the place where it is manufactured to the place where it is sold. So the transportation and storage becomes easier if you can compress the LPG into a cylinder. So when you compress LPG, it gets liquefied, and therefore it is not the gas which it originally was. It becomes a liquefied version of that gas. It is not in your syllabus, but that gas is called isobutane, and the liquefied version of isobutane is what you get inside the cylinder. So today what we are actually going to do is, we are going to talk about we are going to talk about the three features which makes it very easy for us to liquefy a gas. The three things. So what are those three things? The first is low temperature. What are the three parameters that makes it easy for us to liquefy a gas? The first is low temperature. Now, why do we need a low temperature? See, what happens is that when you liquefy a gas, you basically bring the molecules closer to each other. When it is gas, the molecules are very far apart. When it becomes liquefied, the molecules come very close. So you want the molecules to come close. So if you have a low temperature, the molecules will not run here and there, they will not move here and there randomly. They are likely to stay calmly and peacefully in a certain area, and therefore they are more likely to get attracted to each other. So that is why you need a low temperature. So number one criteria that you should be able to liquefy a gas, essentially you should have a low temperature. Once again, a low temperature will ensure that the gas molecules do not have the opportunity to move around randomly. They will tend to be in a certain place and only be confined to that place and not move around randomly, helter-skelter, all sorts of places, moving in a chaotic manner. All that will not happen. If that happens, they are less likely to come close and they are less likely to be attracted. And attraction is a must. Only when gas molecules develop some attraction, then only it can get liquefied. Because remember, compared to gas molecules, liquid molecules have more attraction. So first criteria is low temperature. Second criteria is high pressure. Now the thing is, there's a very interesting thing in chemistry. You will learn about this more and more with the passage of time. There is an inverse relation between pressure and volume. If you pressurize a gas, the volume automatically becomes less. It's very simple. Visualize there is a gas. and then you are pressurizing it, right? You are pressurizing it, so the volume is coming down. Earlier the volume was this much, now you are pressurizing it, volume has come down. So there is an inverse relation. High pressure automatically means low volume. So why do you need high pressure? Why do you need low volume? If you have high pressure, then you are forcing the molecules to come close, right? You are subjecting the gas molecules to high pressure, you are forcing them to come close, and when you force them to come close, that is when they are likely to come close enough to develop an attraction for each other, and due to that attraction the gas can be liquefied. So number 2 criteria for gases to be able to be liquefied is that the pressure should be high. And like I said, high pressure automatically means low volume, because if you subject the gas to high pressure, you're forcing the molecules to come close to each other, so that makes the volume lesser, and that actually low volume is again an essential requirement for being able to liquefy a gas. So you have made the volume low, you have contracted the gas molecules to a lesser volume, so therefore the greater chance that they will develop some attraction, and therefore you will be able to liquefy them. So that is the topic of this video, that if you want to liquefy a gas, number 1, you should be able to have low temperature, number 2, you should have high pressure, number 3, you should have low volume. Among the 3, note that high pressure, low volume is in fact a characteristic, and gas molecules tend to display an inverse relation. When there is high pressure, there is low volume, and vice versa, right? So this is the topic of this video, and there are some homework questions, and the link to the homework is given in the description box below. So please do the homework. You can just submit your answers as and when they are ready. That will be all. Bye all of you.